Welcome back to part two of the of our little Siemens talk here. It turns out that I paused the last recording and then neglected to unpause it again, so I get to make this second video for a second time, and we're just going to sort of pick up where we left off and keep going. So we were talking about five-axis vector compensation in the last video, and I want to talk about uh, the vectors as it is regarded to doing other types of machining. So the now that we've convinced you that vectors are the best thing since sliced bread, because they are, you're going to ask, well, why use ABC commands at all? And here's a prime example. So this facing operation, this is 4-axis axial facing. Not that you would actually machine like this, but as a path, from a path perspective, this is what we requested in Top Solid, and this is the simulation that we're getting. So one of the core principles is that the simulation must match the code. So this type of cut could also be made as a 5-axis cut, but by doing that, we wouldn't actually have the part rotating, we would have the tool going around the part. So for example, here's a simple swarfing I made that's using a 5-axis path. So this is the 5-axis kinematic kernel, where all of the tool vectors are calculated by vectors between the tool and the surface and all that other stuff. So what we're going to see is, because this is swarfing this part at the singularity, we're not actually going to have any 5-axis motion. We're just going to have the tool moving around the part. And this is what happens when you machine at a singularity like this. This is just how the math breaks down, because we can have a case where we might want a rotary to move, in this case the C-axis, but that rotary move is in the same axis as the absolute Z-axis at this point, and there's no other movement in the other X or Y axes to actually get the tool to be off of that singularity. So what ends up happening is Top Solid thinks that the part is rotating and the tool is being stationary. But if you were to output this with vectors, you would have the tool just moving around the part. And we can actually see this mathematically, because the way the Top Solid calculates with vectors is the same way that the machine would also calculate it with vectors. And we can see here that the math breaks down, so that even though this is a 5-axis path, this is just cutting in 3-axis effectively. So what we do here is, in the post, we have a couple of checks, or I put a couple of checks on every motion to see if the tool vectors are changing versus if the part is moving or not. So basically, if we asked the rotary axes to move, and the rotary axes have moved, but the tool vector is not moving or hasn't changed, then we know that we're at a singularity, and whatever we're doing is ambiguous, effectively. So with that check, we can actually output code that's regular ABC code, and we don't have to use vectors for that. And this way, the simulation will actually match the code. So here's that little 3-axis cut that we made. This is what that cut looks like. Now, this is okay, and the reason why this code is okay is because, if you remember in the simulation, those rotary axes stopped moving. So when Cam is looking at this toolpath, Cam realizes that the rotary axes are not moving, and we're just moving the tool around the part. So this code will actually match what Top Solid's outputting, which is what we want. So this is an example of what happens to vectors at singularities. But if we look at this if we go back to that 4-axis axial path that we had, so this axial path, we're still cutting in with 5-axis Traorion, RTCP but we're outputting the C-axis here instead of the vector command, because if we were to output vectors here, the C-axis would not move, and we have explicitly asked the C-axis to move. So this post checks all that and makes sure that that's the case. And the other thing that Siemens does very, very well with, which is 5-axis kind of related, is B-axis turning. So B-axis turning is the spiritual equivalent to 5-axis turning, even though it's really not. So here's a little video of B-axis turning. You can see this is on a WFL machine. You can see the vector of the tool is actually changing as we are cutting the part. So this is a feature function that is definitely considered high-end. Some machines do this really poorly, and some do it really well. The Siemens 840D does this, is the best I've ever seen at this. All you have to do to make this work is you just turn on Rotate Tool Center Point, Priori, and it works. It's that easy. And then the way you control the B axis is just with B moves. So you could imagine the code will end up looking something like this. Let's just say you have some. I realize this arc is not correct or whatever, but the code looks effectively like this, where excuse me, where we have an arc of some sort, and then we just have a B command. So it'd be like B1 equals 50. So you just run an arc like that with the with Priori on, that 5-axis transformation or rotate tool center point, and it does it. So it'll take arcs, it'll take lines, it'll take whatever. But a lot of machine tools, they will not take arcs while using this function. Akuma doesn't, and Mazak doesn't, and so in those cases, all the code is point to point, and it's all linearized with no arcs, and so that's going to not be so hot for your surface finish and other stuff like that, and it's going to make your code whopping long. So Siemens here continues to do this the right way. You just turn on Priori, rotate tool center point, and then you start moving your B around. This also means that on any path, like any approach or retract or link movement type path, you can move the B axis around with Priori with a turning tool without any problem or any special modes or anything. You just turn it on, and then it's on. So lots of other machine tools, like Akuma, they make it a real pain to use this function. You have to, on Akuma, first of all, your angles have to be at 0, so it's like a B0 type thing for a B-axis mill turn. And then you have to unlock the B-axis, turn on like 5-axis mode, and then you have to actually turn on rotate tool center point. It's a 3-step process for something that really should just be 1. And then you also have to end the angles at 0 as well. So you have to start and end at 0, plus you got to turn all this stuff on and then go turn it all off later. So it's a lot more difficult to use. And lots of other machine tool manufacturers have a similar pattern. Fanuc-based stuff usually has that same pattern, like the B-axis mill turn type patterns. Like I think the NTX series, that has a Fanuc on it, or NT series in general that has a Fanuc on it. That has to do a similar dance where it unlocks the B, turns on 5-axis mode, then turns on rotate tool center point. When really you should just turn on rotate tool center point, right? So Siemens makes this so easy to do. It really can't be done any better than the way it's being done by them. So Siemens, talking about that singularity thing, I just went a little out of order here. That singularity thing is, we can change in the code whether we're going from ABC to vectors or back and forth. So if in the middle of a path, like, I don't know, let's just say here, we happened by accident to machine into singularity, this would come out as XYZ, ABC, or whatever, just the regular ABC commands for moving the rotaries, and then it would go back to vectors. So that would break the kinematic independence if that happened, but you would still be getting the path that you asked for, which is more important. Siemens can switch between those modes without having any kind of an issue. This was a little thing I typed in the last video that I forgot to record. And other machines will have vector modes as well. The classic in Fanuc is G43.5, and it uses IJK as the tool vector. And standard Fanuc type machines cannot switch back and forth dynamically between using vectors and ABC movements. So if you this is a XYZ IJK, an XYZ IJK. If on the next line you had an XYZ ABC movement, the machine tool would error out because it does not like switching between stuff. Where Siemens totally can. It can just go back and forth whenever it wants. So in the post, I have it checking to make sure. I've never actually seen it not break down. I've never seen like a 5-axis path break down when it really shouldn't be, and I think that's just because of Top Solid's like good calculation for this. But generally speaking, this should all just come out as regular vector, and then we make the check here, and it comes out as the c-axis movements. If we wanted to, we could actually keep the same link movement and just go right from this path to this path and skip all of this extra, positioning back at home and coming back in. We could just go right from this path to this path, and you would see it would go right from doing c-axis stuff all the way to IJK stuff without having to turn Traore off. So from that, it's it's really, really good. There's not many, if really any other machine tools that can do that. Heidenhain can. Heidenhain can go back and forth. But your regular Finucane derivatives, no way. Not even a little bit. And all this vector stuff, this is just part of the control. This isn't like something extra you have to buy. This isn't like an option you have to buy. If your machine has Traore, you're good. This works. So that's an important thing to remember, especially when talking about pricing and other things like that. You might be able to buy some other machine and maybe it's cheaper, but you're going to have to add on rotate tool center point, plane matrix, option and option and option in the controller. Like in Akuma, having vector output is an option that you buy. It's not like a standard thing you get. And all of that vector compensation stuff, it's also theoretically an option on Akuma machines, although I've never seen one actually equipped with one. But all of those functions just come standard on the Siemens control. That's how the control works. So it's not like a matter of, this extra stuff you have to buy or whatever. It just comes in the control, and it's delivering value out of the box without you having to order a bunch of extra junk and know what all the stuff is and know how it all works. It's just there in the control for you to use. So let's continue. And let's see what else we got going. So cycles. So Siemens has a ton of cycles. They've got cycles for almost everything you could imagine. There's actually a specific manual devoted to just programming cycles. And, if you want a good read, that's certainly a good read. There's options for almost everything. So I'll show you what regular cycles look like in the land of Siemens. Cycle 832. All right, so here's like the equivalent of a regular G81 drilling cycle. So G81, a whole bunch of parameters. I don't know what they mean off the top of my head. When you go into the Siemens control and you select this line, it actually brings up a whole other menu that tells that it's a graphical menu that allows you to change and select all this stuff. You're not just editing it blind. So that's super nice. But just looking at it, I forgot what that stuff was. I'd have to look it up. But it's just one manual away. And you can see it on the machine anyway, so it's not really a big deal. And then change it graphically. But that's basically what they look like. So, they've got the standard G81, G82, G83. It also supports PEC tapping, which is super cool. And a whole bunch of reaming cycles and backboring and a whole host of things. The Siemens cycles support lots of things that are actually not even supported in Top Solid. There's just like not a button in Top Solid to like change it. Like for example, like on tapping, you can have one speed where you tap into the material, and then you can have a different speed when you retract, like RPM wise, which is super super cool. And they've got lots of stuff like that, and Top Solid doesn't even have that. So, they go above and beyond what we support, and generally speaking, we support a lot of stuff. So I want to talk a little bit about just some part transfer stuff. Part transfer can be very difficult depending on what machine you're on, especially Fanuc and Fanuc derivatives. I know I keep picking on them, but I mean with good reason. I've seen part transfers that required, the sun and the moon and the heaven and stars to line up, and everything has to be in the right mode, in the right place, in the right time. And so you end up doing a lot of work in CAM just to make sure that the machine is in the right mode. And then, you have to make the actual transfer itself. This Siemens part transfer isn't really anything that's special. There's one command that actually couples the axes together, and that's it. So it's not nearly as difficult or hellacious as other people make it out to be, or other machine tool makers make it turn out to be. Again, probably the worst one is probably Akuma. Their part transfer is just unbelievably difficult. It takes a lot to do a part transfer on an Akuma, and if you can, you should definitely change whatever part transfer routine that you have into some macro for an Akuma, because there's so many steps to make it work and to get the machine in the right mode. Plus, you have to do stuff like if your machine has a solid model of the part that it's cutting, you have to do stuff like, when you do the part transfer, to copy the model to the subspindle manually and have it pull the part away. Stuff like that, where it's like, really, can't the machine just figure out what's being held and which way it's going and stuff like that? Because it knows if its chucks are open and closed and whatnot. So they're probably up there as being the worst. Mazak's probably second in that. Mazak has lots of weird rules, like subspindle rules, that other people don't have. The way that Mazaks do origins and things is also pretty unintuitive, and it also can change depending on whether you're sort of using a classic mode like EIA mode, or whether you're using their quote unquote Mazatrol mode. So I've seen lots of machines that were basically identical that all had to work in completely different ways for effectively no good reason. So that's a thing. But yeah, on Siemens, you pretty much just couple the axes and go. And then when you're coupled like that, you can switch between, you can do milling and turning when you're linked. So you can hold that part and on both sides and do milling and turning operations. Speaking of milling and turning, simultaneous milling and turning is also easy in Siemens. So you might have a case where you might want to drill a hole, and in Top Solid we can actually just select we can select rotation of the tool and the part, and I selected the tool. It's not at a good angle. There you go. So we can select the tool and the part, and we can actually output different RPMs for each spindle. And to Siemens, this is nothing special. It's just you're turning, and then you turn on the milling spindle. It's that simple. There's not special modes or special interlocks or anything like that you have to be in. A lot of companies also, if you try to do this and then you try to use cycles, they get very angry. So again, this is a case where if you're doing milling and turning like in an Akuma lathe, like an LB, lots of those cycles don't work. Whereas Siemens, they just work. It figures itself out and it moves on. So it's just easy. Let's talk about smoothing. So Cycle 832 smoothing is super awesome. Let's see if I can get back to my code. So Cycle 832, and I guess without really going too deep into it, Cycle 832 is just an advanced smoothing command. What's really nice is that it works the same way no matter what machine you're on. So it's not like Fanuc where is this G5P1, G5P10,000, G5Q1, G5Q1, G5Q0. You don't have all of those like weird differences in smoothing modes where you're like, I don't know what smoothing commands this thing takes or doesn't take or should or shouldn't take. Half the time on those Akuma machines, not Akuma, well, probably those two, but really on the Fanuc machines, it's the smoothing stuff always gets so complicated. Half the time, you don't even know what smoothing command you should be running. Like, do I have AI control, advanced AI control, super advanced AI control, super advanced AI control with a cherry on top. And you don't know what situation you should be turning which types of smoothing on, what the machine's equipped with, etc. Whereas, Siemens, you want to turn on smoothing, it's one command. It works the same everywhere, and you just move on. You don't have to worry about, if it's equipped with this or equipped with that. It also, Cycle 832 also can apply smoothing in 5-axis as well, so that's a huge positive. Let's talk about G-code simulation, and let's also talk about just offline machine simulation. So, lots of you are probably familiar with Vericut or NC Simul. There's lots of other ones out there too. But all of those third-party packages are exactly that. They are third-party packages provided by some other company, and a lot of them are great. Like, I've used Vericut. I love Vericut. Vericut works amazingly, and TopSolid also has an export to Vericut. But what's different about Sinutrain is Sinutrain is actually a Siemens product. So you have a machine with a controller from Siemens, and you actually can get the simulation software from them as well. So if you have a whole bunch of machines, I would highly encourage you to go get Sinutrain. Sinutrain also can take your exact machine configuration right out of your controller, import it, and you can have a model of your machine in Sinutrain that's identical to your real machine on the floor. And that's not something that I'm aware of that really anybody else offers. So I would implore you, if you have Siemens machines, if you spent the money to go get them, buy Sinutrain. It's not very expensive. If you don't have Sinutrain, you can always try it out online. There's a free version. I have the free version on my computer, and it's great for just testing little things and whatnot. Obviously, I don't cut parts, but if you cut parts, you could try it out on the just the free version, and then as things progress, you can go buy it. But it's a great thing to have. So now that we've talked about why the Siemens 840D is the best controller and why you should buy a machine with one, let's talk about where you can get machines with the Siemens controller. And the number one place is DMG. So DMG, they make amazing quality machines. Yes, they are a little pricey, but you get what you pay for. And that's a secret it's an open secret, I would say. A lot of people say, well, I could go get this, junky whatever machine for this price. Yeah, but you're going to get what you pay for. So I would implore you to buy once, cry once. I've seen lots of companies that bought lesser machines and then they tried to use them or, struggled with them, et cetera, and then they ended up buying a more expensive machine later anyway because the other one just wasn't cutting it for them. Pun intended. So I would say start off with something good. Obviously, if you're a dude in a garage, you're not going to probably be able to get a DMG level thing. You're going to be looking at the used market very heavily, and also, that's kind of like a Haas thing. But if you're out there and you're cutting parts and you need your parts to be like correct and accurate and right, go get a DMG. If you need more than what DMG has to offer, there's lots of other tiny guys out there. I couldn't think of any, like Micron. Micron's a good one. They make ridiculously precise machines. You can get Siemens and Heidenhain and stuff on those guys too. So if you need more, you can always go more, but I would at least start at DMG and then go up or down from there. So if you want big capacity, big bore stuff, like very big parts that, we're not talking about inches anymore. We're talking about meters. Then you should go buy a WFL. So WFL is a company. They're a German company. Big surprise, right? And where are they? Here we go. They make big stuff. So here's the M200. So this part, as you can see, is pretty big. And this is not even the biggest thing that they make. This is what I would say is one of their smaller ones. So we have customers that have parts that make parts for very critical applications that absolutely have to be correct. And they're big. And they use WFLs. and the customers that that we have that have adopted WFLs, they like them. They should for the price. These things they're well over a million. They are in. If you could get one for a million, it's probably a steal. You're probably looking closer to 2 or 3, depending on what you get. These also, the WFLs have specific magazines that have very large, like boring tools and boring bars in them, specifically for doing big work. So that's the way to go. WFL does use Siemens 840D, but they have a whole bunch of extra code that is specific to WFL that they have written on top of it, just to help with some of their very specific applications. There's also other manufacturers that you can get Siemens 840Ds on. I was brought to my attention that Doosan also offers a 840D type solution, and Doosan, is probably a good place to go. They're not overly expensive, but you're still getting a good quality machine tool mechanically. So if you can get a Siemens or a Heidenhain on a Doosan, I would definitely do it. There's probably other guys out there too. There's lots of little machine tool companies now. I would ask whoever your favorite supplier is, just do you offer Siemens 840D? If I bought a machine, would you fit a 40D on it for me? A lot of times they'll just say yes. So I would definitely start off by going that route. So let's say now, your question might be, well, what's a great 5-axis machine to start off with, right? Maybe you've done a little bit of 3-axis work. Maybe you've even done some 4-axis work. But where do I go from here? Like, what should I buy that has a 840D on it? And the answer is, if you just want a regular 5-axis machine, start off with a DMG DMU50, 3rd gen. They're about $300,000. For that price point, its performance is absolutely unmatched. There's some great videos on YouTube. John Saunders has a couple of videos on them. The types of finishes and surface finishes that are possible on that machine out of the box are mind-blowing. And it's only a $300,000 machine. The only other machine that could rival its value, not performance, but value, would be like a Haas UMC 750. And those are like $150K, but they're not even they can't even hold a small candle of performance to a DMG DMU50. They just can't. I forgot if I talked about this in part 1, but there's also a feature that you can buy on a bunch of DMG stuff, machine vibration control. And machine vibration control is basically it's a monitoring system that is actually looking for tool chatter, and when your tool starts chattering, it will actually pulse the servo motors inside in such a way to cancel out the chatter and vibration. And the end result of this is better surface finish, but you also can take bigger cuts and just have higher cutting tool performance. So you can take the same tool and just get more out of it by suppressing that chatter and keeping that tool in the cut without having it bounce all over the place. And then that would also improve tool life. So 5-sided, start with a DMU50. If you want more, you want something bigger, go look at like a monoblock, monoblock 85 or something like that. Those are bigger, heavier machines. So if you want a B-axis mill turn machine, go get a DMG CTX. Again, we have a case where nobody's really providing this level of value at this price point. You can get these for I would say maybe 500 would be on the low end, but probably 600,000 to million plus, depending on what you buy. They have small ones. They have very big ones. They have B-axis, obviously, and they also have regular turret style as well. So I would start with a DMG CTX. I would also say that you should definitely buy the B-axis head 5-axis version instead of the turret version. Just because you spend all this money and whatnot, you should have that 5-axis versatility that that kind of machine really just deserves. So I would start with the CTX and pick something in that range. And if you want bigger, more badass type turning, B-axis type machine, go get a WFL. So that's kind of what's in town, really. for stuff that's really good in that realm. I've seen there's other stuff out there too, like CB Ferrari. I think I've seen a couple of those machines with Siemens on them. Uh, I know there's a lot more, but there's more and more B-axis stuff all the time. Uh, I know that Doosan offers a B-axis mill turn machine. I would have to ask if that is offered with the Siemens. If it is, I would definitely buy it because the Doosan B-axis mill turn is a great value for money. Um, so, yeah, I would also say, for all this, I would definitely go make sure that you buy something that's 5-axis. I've seen so many companies start off with a 4-axis machine and then have issues and then end up needing 5-axis and buying a 5-axis machine later. It's not, despite what you might think, it is not as efficient to take your part out of a 4-axis horizontal and put it in another 4-axis horizontal and do that again and again and again when you could have just had a 5-axis machine do it in one shot in one setup. And I see that mistake all the time. If you have one rotary, you should have two rotaries. That's the bottom line. If you want a 3-axis machine to do 3-axis things, that kind of makes sense. I can't really argue with you there. But if you want to take something in 4-axis, you really are going to end up needing 5. So buy once, cry once. Make sure you get 5-axis, and go about your business making parts. A couple other things which are super cool. I've had good experience with the support. Like I had a question on Sinutrain the other day. I couldn't get something to work, and I called Siemens about my Sinutrain issue, and I also explicitly told them that I'm like not a paying customer, and I was just using their online free version. And they got back to me the next day and resolved my issue immediately, even though I haven't spent a dime with them. So I would say their support's great. Another thing that's really cool is the training that they offer. So there's this website called CNC4U, which is part of the Siemens website, and they've got all kinds of wonderful goodies on here. Let's see if I can get to the. It's on the numeric for you. Oh, great! My internet's not doing so hot. All right, so come on, you can do it. There we go. So this website is amazing. So the CNC4U website, they have a lot of stuff here. Under education and training, I think it's machine tool training. Yeah, so you go to machine tool training, in-person training. All of these are classes that are offered here in Elk Grove Village, which is a suburb of Chicago, and I live in the Chicago area, so that's kind of cool. But all these in-person trainings are free. I'm registered for one, in just for fun, in like a month or two. And so you've spent all this money buying this great machine tool, and you're going to be productive and make all your parts, and everything's going to be right and correct. Take advantage of this free training. It's free, and it's in-person training. Why wouldn't you take advantage of it? The other thing that they have is a wonderful library of webinars, which are always growing all the time. So they have, so these webinars. So there's a webinar actually going on right now about doing some shock turn stuff. So they have an archive of all the webinars that they've previously done. So all sorts of stuff. Here's one on variable programming, standard cycles, working with shop turn DXF programming, 5-axis machining. Look at all this, all of these. Each one of these is well over an hour long. There's plenty of stuff in each one of them. And that was just milling. There's also general and turning. There's a whole bunch of stuff in here regarding turning and maintenance. So, this probably doesn't cover everything, but man, they really do cover a lot. I would definitely say if you want to really become an expert in the 840D, take a look at some of these. You don't even have to listen or watch that intensely. Just sit there and absorb it. Listen to this while you're doing dishes or something. There are so many wonderful nuggets and just great little pieces of information you can get. Like here's one on Cycle 832 for smoothing. As far as I'm aware, nobody else really has a resource available like this. There's not Kuma webinars or Fanuc webinars or Mazak webinars that are just online and free. So all you got to do is click view the recording, and you can play it back here in your browser, or you can do download and play it right off your computer. You can install the little web player. You can also play them on your phone. They're great. So I would definitely take advantage of this. The guy who does this, his name is Chris Pollock, and he's probably one of the best, if not the best, person out there to do training and all this sort of stuff. He's a wonderful speaker. He does a lot of. He speaks in a way where he's not going over people's heads, but he's still getting the point across. His webinars, basically in summary, his stuff is way better than mine. So you should just watch whatever he does. So I would definitely take a look at that. I've talked to him in person too. He's a really nice guy. So take advantage of that. And then also you can find on the same CNC40 website, there is document like Siemens 840D documentation. So if you type in what I type in here, no, that's just my little research. Siemens programming manual stuff pops up, so you can access it here. But you can also drill down into the menus in here, and you can actually just directly find it. I think if you just search it in Google, the stuff that it returns is not the most recent. But if you dig into the website a little bit here, you can get the most recent manuals. The most recent manuals that you're going to need are the fundamental programming manual, the job planning manual, and then the cycle programming manual. Those are the three you'll need for the full set of manuals. So that should definitely get you where you need to go. There's also a great guy on YouTube, and let's see if I can find it. Mr. CNC. So this YouTube channel is a great outlet for Siemens type related technical content. These videos go on and on and on about all sorts of stuff. So between the webinars, Mr. CNC, the help and support line, the manuals, there's a lot of people who are rooting for you to help you win. So I think that's it. So I guess if you have any questions, you can just send me a quick email. My email is jaykinzie@gmail.com. That's JAYKINZIE@gmail.com. And just shoot me an email if you have any questions. You could probably also post down in the comments. And hopefully this video was useful and informative to you. And hopefully your next machine will have a Siemens controller on it. So thank you for your time and have a wonderful day. Bye.